Okay, so now that we have actually cleaned the file and we have converted the format, so it's clean.hccap. You can name it any way you like. It doesn't need to be called clean. You can call it however you choose and please. So let me go ahead and show you something here. Let's just use a. I will explain what all of this means. But let me just go ahead and use it first, and then show you the output of the HashCat so that you understand certain things here. So first of all, it gives a device listing. Okay, it recognized both of my GPUs, which is great because it's using both of them. Fantastic, right? But it doesn't give a live output to the screen. You manually have to request for the output, and it has here status, pause, resume, bypass, checkpoint, quit. So I'm just going to go ahead and press S, and as soon as I press S, it gives me the output down below. Okay, so you have a session name, you have the status, it's running, you have the mask that's being used. I will explain masks. And you have the target, hash type, the starting point, the starting time, and the estimated time to completion. And then you have the speed, and this is what I really wanted to show you. So I don't have 3 devices, I actually have 2 devices. It says device 1 and then device 2. And it says that device 1 is 86,244 hashes per a second. Okay, but the second device, this is immediately ridiculously more than the CPU. And then it says the speed of the second device is 101.9 kh/s. What is a kh/s? Well, basically you multiply this by 8,000. Let me show you a diagram. So kh is 1,000 hashes per a second. So 1 kh/s is 1,000 hashes per a second. Mh is basically a million hashes per second, and so on and so forth. So you see immediately we've went from 10,000 keys per second to basically going to 188,000 keys per a second. Do you see the difference? I mean, it's enormous. And that was my phone ringing in the background. The difference is enormous. I mean, it's hilarious. Just how we went from 10,000 to 188,000. So this just gives you this individual speed on the devices, and this gives you the total speed here. And it gives you the progress listing, so what percentage is done, how many has it finished, and how many more it needs to complete. And it gives you the temperature as well. So if I print status again, just keep pressing S for continuous updates, and you will see these numbers might vary and change depending on what is going on. And if you just keep pressing S, it will keep telling you. So the utility is working rather well. It's 98%, which is something that we're aiming for. The megahertz per the core and the memory, the frequency per core and the frequency of the memory. And if I just keep pressing on S, it's just going to keep updating the status board. So it's completing this particular mask rather fast. But I'm going to go ahead and press quit because you need to take a look at this command and understand what it actually is. So first off, actually, you know what? Let's type in HashCat --help. So learn to use help, seriously. And the reason why I'm using it here is because I have a wonderful way of demonstrating things to you. So first of all, this here is -m. It specifies that we will be cracking the VPA2 password. The mark for that is 2500. Okay, so let's go above. Should be around here somewhere. I mean, there's a lot of options here, but there we go. It should be somewhere in this listing. The listing is quite large, and I don't know if I can find it now, but it doesn't really matter. Actually, you know what? Let me use a really stupid trick here and type in hashcat dash help grep 2500. And as you can see, it says 2500 VPA, VPA2 network protocols. Okay. So this -m 2500 stands for VPA, VPA2 protocols. You have a ton load of other things which you can attempt to crack. I mean, anywhere ranging from operating system passwords to router passwords to general hashes to SHA-520 crypt. Actually, SHA-256 is used a lot. NTLM, NTLM, I think this is for Windows. For the SQL databases, you can do a lot of things here, my friends. A lot of things. Okay, so the -a is the method of attack that we will be using. So method of attack is number 3, which is the brute force. Let's go up. So mode, it's basically 0 for straight, combination, brute force, hybrid mask. But no, we're selecting a brute force. And the brute force attack here is not what it basically seems to be. Because the brute force attack is basically when you give the masks. So you can give one mask, or you can use a file with listed masks in them. You can find these files there where you've actually extracted HashCat. So you can make your own files with masks. So masks. And there you go, you have these masks. Let me just show you how they actually look like. And there you go. So these are the predefined masks with the characters that will be inserted. These are placeholders for certain sets of characters. Let me go ahead and show you. Okay. Let me go ahead and show you those sets of characters. Again, we'll use the hashcat --l because here they are listed. So the L basically is lowercase letters, U is uppercase letters, D, that's numbers, S is special characters, and A actually represents all 3 of these, sorry. Actually all 4 of them. And you have B for hexadecimal ranges. Okay, so that's something that you should be aware of. You need to know this. This is very important to you. Without it, you won't be able to actually perform these sort of attacks. Okay, so let's go ahead and but even the fastest GPUs, even if you combined like 4 of them, you still wouldn't be able to crack certain passwords within any reasonable amount of time. Why? Well, because they are huge. They are massive. Those numbers are beyond reckoning. If you go up to 10, that's if you use like uppercase, lowercase letters, and if you go up to 10, ooh, that's a lot. But since we can create our own masks of characters, and you might say something like, well, Ermin, I don't know anything about the password. How can I create a mask for it if I don't know anything about a password? Well, there are some general assumptions that anybody can make in regard to the wireless passwords. I mean, really, anyone can make. The first assumption that you can make is that the password is not shorter than 8 characters, so there's no need to waste time with those that are shorter, with masks that are shorter than 8 characters. So that's the first thing that you need to figure out. The second thing that you need to figure out is that, that most of the passwords out there, I've seen a lot of them, and most of them, they start off either with a lowercase letter or with an uppercase letter, and there are a few letters, and then there are a few numbers. So most passwords are like that. I have rarely seen anybody use any sort of special characters in the wireless passwords. Now, me being me, I have a little bit of a different story, but generally, no. For example, what I've seen in the coffee shops that people generally use, the syntax for it is something like this, what people generally use in coffee shops. So name of the shop. Now this first can either be uppercase or lowercase. It's usually the lowercase, and then they place in some sort of a date, like 2016 or something like that. So when you create the masks, you can create the masks which immediately start with letters. But you can also, I've also seen a lot of personal passwords which people have shown me, and I've basically when I come to somebody's house, I connect to the wireless and they give you the password. Well, they follow pretty much the same syntax. It's usually some sort of a name and then some sort of a date. So it's usually the combination of those two, but in general, it's the combination letters plus numbers, and almost all the wireless passwords are like this. I have rarely seen anything else. Now, you also have it within you to, you can also figure out what is the default wireless password from your ISP provider, because they generally have those pre-built into your routers. So they give it to you on a piece of paper, so they don't have to bother with people who don't know how to set their own passwords. And if you can figure out what is that default wireless password, maybe it's not the same for everybody, but the logic in which it is generated is the same for everybody. For example, my wireless provider had a unique wireless password for each person to whom they issued a router. Okay, that's great. But the problem was that it was of minimal length, which meaning 8 characters, and it was all capital letters. So it was a 1, 2, 3, 4, 5, 6, 7, 8. So you had 8 capital letters. So all the people who didn't change their wireless passwords were stuck with 8 character capital letter password, which can be broken ridiculously fast. I'm pretty sure that you could break this even with a CPU without bigger problems. Now, this was hilarious. And a lot of people don't know how to change the password, and they can't log into the routers to change them because the ISPs lock them. So you have to call your ISP and ask them to change your password in accordance with whatever you want, which is something that not that many people do. They just stick with the default one. But what I'm trying to tell you is that the general syntax for these passwords, and we'll see how we can turn that to our advantage by creating our own ruling list for the passwords. Anyway, I'm gonna go ahead and cut the tutorial here, and we'll continue in the follow-up.